I'm sharing a screen from my a window from my computer. Can you see this?
Yes, I can see SMS present.
Yeah, fantastic. So yeah, let's go. So this is an output from a Sega Master System emulator I've got on my computer. So it's well, I'll go more into that in a bit. But yeah, I'll be running this session on day one at about 10 past 2 in the afternoon. So if you find this interesting, please come along. Or if you find fast HTTP more interesting, or if you like Ruby scheduling more interesting, there are other tracks as well. Anyway, so here's this. This is an application I wrote, and I'm calling it SMS Present because it's the presentation tool that runs on Sega Master System. So let me just go into this. So this is a text that describes the screen, the presentation. I'm going to be talking about mruby in the 8-bit world, mruby virtual machine on Zilog Z80 at RubyKaigi this year, next week. And well, this is as I said, this is the presentation app running on Z80. Actually, I forgot to show, but is my camera also on at the moment? Can you see the camera as well? So I've got a Sega Master System, actual Master System hardware. So, and I'll be running the presentation on the Master System at RubyKaigi, but I'll be I'm using an emulator at the moment. So yeah, I've been talking about this app, and I'll just explain a little bit more about this app. This is running on the 8-bit VM that I have wrote for Z80, and it has got some text and images, but the title screen is the only image that I've managed to do. And at the bottom of the screen, there are a couple of mysterious creatures. Those are indicators for the pages and time, but that's the extent of graphics. Everything else is text. And I wanted to do multicolor text, and I accidentally implemented this feature where I can turn everything into red. This is if you used to play JRPG, this is the sort of stuff you get when someone dies in a battle. But right, so these are the features of this thing. And also, yes, I've added Japanese support. This app can show Japanese text, but I'm not going to be using it this time at RubyKaigi. And also, actually, I was talking about multicolor text, and I've actually managed to do multicolor text, but due to many limitations of Sega Master System, which is an 8-bit console from the 80s, I have not managed to use more than 2 colors. And that's the app. And about myself, I'm Yuji. I'm based in Tokyo. I'm involved in ko.rb. You can find me on ruby.social, and I work for an Australian startup company called Sega. I don't use a lot of Ruby at work, but yeah, this is my hobby. So, and also, for this session, I wanted to explain in detail about what this is really about. In the actual RubyKaigi session, I'll be probably going over a little bit light on this matter, this topic, but at this point, I'd like to go in a bit more detail about what this is. What my project is about. So it's about running mruby bytecode on my own virtual machine implemented on Z80. And the source code is available at Codeberg. It's mirrored on GitHub as well, but the Codeberg is the main repo. And at this point, I wouldn't be surprised if lots of people are going, what is mruby and what is bytecode and what is VM and what is Z80? And that's exactly what I'm going to explain over the next few minutes. So mruby, you might not be aware of, but if you might know about mruby, but if you don't know what it is, it's lightweight Ruby. So JRuby is an implementation of Ruby, and cruby, which typically is the Ruby executable when you don't really care what implementation you're using. And also there are other things like truffle Ruby, and there's mruby, which is primarily for embedding into your C programs or probably other languages, and also suitable for small environments. And there are many variations. Main original mruby and mruby/C, which is a even more compact version of mruby, and pickle Ruby and femto Ruby are the ones that come with Ruby bytecode compilers, which I'm going to explain about in a minute. But these pickle Ruby and femto Ruby are mruby and mruby/C that come with Ruby to bytecode compilers. So, and also RubyVM, you might not be aware of it, but Ruby runs on a VM virtual machine, and virtual machine is a machine inside a machine. You might have an Intel or ARM processor on your computer as physical processors, but on top of it, you can implement a virtual machine which executes the common instructions across different CPUs. So yeah, obviously, JVM is the VM that is can run the same bytecode over different platforms. Very similar kind of thing. But you might not be aware of this, but when you run Ruby, say, do type Ruby hello world.rb, then that is the source. Ruby itself is not directly executed, but it's usually compiled into bytecode first, then it's executed. And the VM executes the bytecode, and so you might be going, what is bytecode then? So it's the VM instructions, and it's the produced by mrubyz, which is the bytecode compiler for mruby. And Ruby source is first tokenized into token string, then parsed into abstract syntax tree, then code generator generates instruction sequence. That's the compilation process of Ruby. And bytecode is typically simpler than each instruction is smaller and simpler than Ruby statements. And mrubyVM is a register machine, and crubyVM is a stack machine. I'm not going to go into details, but they're a little bit different in architectures. And here's an example of Ruby and bytecode. So take this Ruby code, return 3 = 2, which compares 3 and 2 and returns the results, which is obviously false. And when you compile this into bytecode, it produces the compiler produces something like this. I've highlighted the important bits in yellow, so what this is telling is that the first instruction says load the literal 3 into register 1, and the next instruction says load 2 into register 2, and the third instruction says run equality operation between register 1 and register 2 values. And it's not explicitly stated, but EQ operation overwrites register 1 with a result which stores false into register 1. And the next instruction says return register 1 and stop. So a simple single line statement like this turns into this sequence of bytecode. So it's each step is a bit simpler, but it's a little bit more like an assembly, bit like assembly language in a sense. And so how do we use this bytecode? Well, mrubyz can output C headers, and then it outputs sequence of integers that represents the bytecode, and that can be included in your C program. And you can write a VM that can read this, that reads and executes this. And also, at this stage, earlier I mentioned there's mrubyz and mruby, and mrubyz is a smaller mruby and VM only. So what that means is in mruby, compilation step and execution step are separate. So on your host machine, on your PC, you can compile your Ruby source into bytecode, and then you can use that bytecode, like build an executable using that bytecode, and then run that on a separate environment. So in mruby, those steps can be very separate, and mrubyz only provides the VM. So if you're using mrubyz, you're probably using another compiler, typically the main mruby and distribution. And also, this was inspiration for my 8-bit VM. It has got a lot of ideas. It has got a lot of cool features about keeping the footprint small, and also, yeah, it was a VM-only project that I thought was really cool because you can just use the same bytecode compiler from mruby. And also, I've been talking about Z80, and Z80 is an 8-bit CPU that was very popular in the 80s, and the production started in 1976 and stopped in 2024. And many platforms use this: Sega Master System, Game Gear, and also MSX computers. And also, if you're familiar with the Sinclair, or yeah, there are a lot more like Texas Instruments calculators also used Z80. So in this instance, I'm using a Master System emulator. And so Master System is oops, this display is not very good, but the Sega's video game console that used Z80, and very similar to what's called Sega Mark III. And it runs Z80 at 3.5 megahertz, and it comes with 8 kilobytes of RAM. So the environment is very limited, and hence my VM doesn't have a lot of features. It only implements very small subset of Ruby. And address space is 64 kilobytes, and ROM is typically at 32 kilobytes. And video RAM is 16 kilobytes, and it's rather limited. And the graphics are like all video games, HALs and sprites, and you need to use color palettes. And you might not be familiar with ROM, but if you buy a game cartridge, I don't know if you know of game cartridges because that's so old. But if you know about Super Nintendo or Mega Drive, those game cartridges, you used to be able to buy ROM cartridges that were basically ROM chips. And what happened was that if you buy those and insert it into your console and power on the console, those were memory chips that was in the same address space as your console's RAM. Next to RAM, you could read the contents of the game cartridge, but those are ROM, read-only memory, so you could not write to it. So unlike when you buy a CD or DVD or Blu-ray, I guess these days, and games distributor on those things, on those optical media, you have to read into your RAM first, but that's not necessary with when you're distributing games in ROM. And also, Mega Drive is compatible with Master System, but that's not particularly important in this context. And so this comes back to this. This project is about running mruby bytecode on my VM implemented on Z80. And I'll be talking about this on day 1 at 2:10. Thank you very much. So see you there.
Hey, Yuji, could you see the title link in the next chat?
Oh yeah, I've got the link.
There are some interesting comments.
Yes. Can we run mruby code on Game Gear console? Yes, indeed. I mean, with my VM running on Master System, I think it can just Master System and Game Gear are very compatible. So I think it can just run on Game Gear. I don't have a real Game Gear, but I'm pretty sure the same executable can run on Game Gear. And also another question I see, community in Japan seems really into tiny hardware these days. What do you think about this trend? Any RubyKaigi thoughts? Yeah, yes. Pickle Ruby is quite popular now, and I know a lot of people working on Pickle Ruby, and I have been working on a Pickle Ruby based device myself as well, and it's great that feels like it's taken a while, but finally embedded Ruby is finding its really getting its traction, finding its niche. And I generally like I know most people who are doing the Pickle Ruby related talks, so I'm interested in most of this. So yeah, those were the questions.
Well,
you can see.
Yeah, you will ask, how do you make Chinese text available to display in Z80?
Oh, it's a very interesting topic. Well, everything in Master System, in Master System, the graphics is tile based. So I don't know. So you have to make everything into 8 pixels times 8 pixels tiles, and then you have to put that in your ROM, and from your ROM you have to copy that to the video RAM, and you have to tell the video controller to please show this tile at this point, and please show this tile in your video RAM at this location of your screen. So that can be anything. It can be part of like bricks, or part of your tree, or could be another background, some background element, or it can be any language letter, but it's 8 pixel times 8 pixel. And I found this Japanese font that is amazing, that does 7 times 7 pixels, tries to do a lot of a lot of Japanese, including the kanji characters, and it's often not readable on their own. But when you put them in when you put them in a long enough phrase, it's readable because of the context.
Okay, thank you.
I think it's possible that we do it in 2D, like RubyKaigi.
Yeah.
Yeah, that's another alphabet system for Mandarin in Taiwan, and it is a bit similar to Hiragana. So maybe that's possible. Yeah, like if you don't make one.
No, not possible.
Yeah, you can contribute and you apply to the next CFP of RubyKaigi. Okay. So any questions? No? So let's move to the next session. Thank you, Yuji.
Thank you.